Alright, so this is on section 6.3, which is on tests for population proportion. So before we do an example, let's recall by the central limit theorem that the estimator for the success rate p hat has a normal distribution with mean being the true value of the success rate and the variance being p times 1 minus p over n. We're going to use this to do our tests for a population proportion. So let's do a simple example. So let's toss an unknown coin 100 times. And then among the 100 tosses, 40 of them are heads, which implies 60 are tails. So that's a little off because if it's fair, then we should have 50 heads and 50 tails, but we only have 40 heads and 60 tails. So our guess is that the coin is not fair, which is the alternate hypothesis. So coin is not fair means the success rate is not equal to 0.5. And the opposite of alternate hypothesis is the null hypothesis, which says that the coin is fair. Okay, so let's take the null hypothesis and draw the null distribution. So the null distribution is taken from the central limit theorem. So it's the normal distribution with mean being 0.5, variance being 0.5 times 1 minus 0.5 over 100, which is the sample size. And if we calculate this, this is equal to 0.05 squared. So the null distribution has mean 0.5 and standard deviation 0.05. And then let's calculate our p hat. So we toss it 100 times, 40 of them are heads, so our p hat is equal to 40 over 100, which is equal to 0.4. That's about here. And because this is a two-sided test, so we need to calculate the area of the two tails. So we need to calculate the area of the left tail, and then we'll have to calculate the area of the right tail. So before we calculate the area, we have to first find a z-value. So to calculate the z-value, we subtract the mean divided by the standard deviation. So this is -2. So for the other tail, z is equal to 2. So now if we look at the z table, each of the tails has area 0.0228. So the p-value is twice of 0.0228, which is 0.0456. And the default value for alpha is 0.05. So because the p-value is less than 0.05, we reject h0 at this level. So which means we accept h1 and conclude that the coin is not fair. Alright, so let's do a different example. So we want to estimate the fatality rate of a disease. So let's suppose 10,000 people are infected by this disease. And among the 10,000 people infected, 121 died from this disease. So our p hat is 121 divided by 10,000, which is 0.0121. So we want to accept that the fatality rate is greater than 1%. So that's our alternate hypothesis, and the null hypothesis is the opposite. states that the fatality rate is less than or equal to 1%. So P is the fatality rate. Okay, so we can take our null hypothesis and draw our null distribution. So the mean is 0.01 and the variance is 0.01 times 1 minus 0.01 divided by the sample size, which is 10,000. And if we use the calculator, the standard deviation is equal to 0.000995. Okay, so let's draw our null distribution. The mean is 0.01 and our p hat is 0.0121. So because this is a one-sided test, so all we need to do is to calculate the area of this tail, and that's our p-value. So to calculate the area of this tail, first we find a z-value, z-score of 0.0121. We subtract the mean and divide it by the standard deviation. You use the calculator, the z-value is 2.11. And if you look at the table for 2.11, you'll find out this area of this tail is equal to 0.0174. So the p-value is 0.0174, which is less than 0.05. So we can reject H0 at 5% level, which means we accept H1 at 5% level, which means we can conclude that the fatality rate is greater than 1%. Alright, so that's it for section 6.3.